Hi everyone. In this video, we're going to look at how to graph rational functions in the form ax plus b divided by cx plus d. What I'm going to start by doing is in Desmos, I'm going to graph rational functions in this form, 8x divided by nx plus 1, for different values of n, then find the equations of the vertical and horizontal asymptotes. And the reason I want to do that is to see if I notice any patterns between the equation and the vertical and horizontal asymptotes. So I'm going to open up Desmos and let's take a look at this equation for different values of n. So when n is equal to 1, well, to find the horizontal asymptote, we want to look at what is the horizontal line my graph approaches as we go further and further to the right or further and further to the left of my graph? Well, you might notice as we're going further and further to the right or as we're going further and further to the left, my graph here seems to approach the line y is equal to 8. And I can show you this, but if I graph the line y is equal to 8, and this will make things a little bit clearer, right? My graph approaches the line, the horizontal line, y is equal to 8. So this is my horizontal asymptote here for this graph. Okay, to find the vertical asymptote, we need to find what vertical line does my graph approach. And it seems like just by looking at this graph, it looks like it's approaching the line x is equal to -1. And if we graph that, it'll be easier to see. So we can see, okay, when n is equal to 1 here, the horizontal asymptote is y is equal to 8, and the vertical asymptote is x is equal to -1. And we can keep going, right? If n is equal to 2, well, this time you'll see, okay, my graph is going to approach the horizontal line y is equal to 4. So I'm gonna change my equation there. And that's going to be my new horizontal asymptote. And my vertical asymptote, well, this line is going to approach x is equal to -1/2. Right, and we can see that by graphing the line. Okay, so when n is equal to 2, my graph approaches the horizontal line y is equal to 4, and the vertical line x is equal to -1/2. And we can keep going. We can try n is equal to 4, and you'll notice the same thing, or something. Sorry, not the same thing, but something similar. Right? When n is equal to 4, right, my graph is going to approach the horizontal line y is equal to 2, and it's going to approach the vertical line x is equal to -1/4. Right? And we can see that better by graphing the vertical line as well. Okay, so there you go. So we tried some different values of n, and we found the horizontal and vertical asymptote. So I'm going to write those. I'm going to write I'm going to write the equations of the asymptotes that we found. So we found, okay, when n was equal to 1 in our function, that our vertical asymptote was -1, and our horizontal asymptote was 8. Okay, when n is equal to 2, we found that the vertical asymptote was x is equal to -1/2, and the horizontal asymptote was y is equal to 4. Okay, we found, okay, when n is equal to 4, well, my vertical asymptote was x is equal to negative 1 over 4, and my horizontal asymptote is y is equal to 2. So you might notice something. You might notice a relationship here. So if you take a look at the horizontal asymptote, for example, okay, when n is equal to 1, the horizontal asymptote is y is equal to 8. When n is equal to 2, it's y is equal to 4. You might notice a couple things there. So first, the equation of my horizontal asymptote is in the form y is equal to 8 divided by n. Right? Because if you see, if 8 is equal to 1, well, so if n is equal to 1, 8 divided by 1 gives you the horizontal asymptote. Right? If n is equal to 2, 8 divided by 2 gives you the horizontal asymptote, and so on. Right? When n is 4, 8 divided by 4, that's going to give you the horizontal asymptote. The vertical asymptote, on the other hand, represents the value of x that makes the denominator equal to 0 in my equation. Right? Because when n is equal to 1, the value of x that makes the denominator equal to 0 is x is equal to negative 1. Right? When n is 2, the value of x that makes the denominator equal to 0 is negative 1 half, and so on. So that leads us to a couple of observations here. The first one, if you're given a rational function in the form ax plus b divided by cx plus d, well, if you want to find the vertical asymptote, you just need to find the value of x that makes the denominator equal to 0. And a caveat I need to add to that is this value of x should not make the numerator equal to 0. So, the vertical asymptote. Find the value of x that makes the denominator 0, but does not make the numerator 0. And most rational functions in this form will have a horizontal asymptote of y is equal to a divided by c. Okay, let's take a look at an example of this. So, say I wanted to sketch the function f of x is equal to 4x minus 3 divided by 2x plus 3. Well, we can start by finding the equations of the asymptotes. Now, remember, to find the equation of the vertical asymptote, what I can do is I can find what value of x will make my denominator here, 2x plus 3, equal to 0. And to figure that out, okay, first to solve this, I can move the 3 over to the other side by subtracting 3 from both sides. And then to get x by itself, I'm just going to divide both sides by 2. And now there we go. There's my equation of my vertical asymptote. X is equal to negative 3 over 2. To find the equation of the horizontal asymptote, well, we just looked at that. So if we have an equation in this form, the equation of the horizontal asymptote is in the form y is equal to a over c. Okay, a here, that's the number in front of our x in our numerator. The value in front of the x in the numerator is 4. So a is equal to 4 here. And c, that's the value in front of x in the denominator, which in this case is 2. 4 divided by 2 gives you 2. So the equation of my horizontal asymptote is y is equal to 2. Something else that can help us graph equations of this form is finding the intercepts as well, the x and y intercepts. To find the y-intercept, what we need to do is we need to set equal to 0 in our function. And when we do that, we'll get okay, again, I'm just going to replace in our function here, I'm just going to replace the x's by 0. So in place of x, I'm just going to plug in 0 in my function here. Okay, 4 times 0 minus 3 just gives me negative 3. 2 times 0 plus 3 just gives me 3. Negative 3 divided by 3 gives me negative 1. So my y-intercept is negative 1. And now to find my x-intercept, what I'm going to do is I'm going to set y is equal to 0 and then find x. So in my equation here, I'm going to set y is equal to 0 and then solve for x. Okay, so to solve this equation, well, okay, I have a 2x plus 3 in the denominator. Well, whenever we have a fraction, a good idea to, like, if you're trying to solve, in this case for x, is we can try to find a way to cancel out the denominators. And we can cancel out the denominator here by multiplying both sides by 2x plus 3. So if I multiply both sides by 2x plus 3, on the left I get 0 times 2x plus 3. And on the right, this 2x plus 3 is cancels out. So I'm just left with 4x minus 3. Okay, on the left, 0 times 2x plus 3 gives you 0 is equal to 4x minus 3. Okay, to solve this, I can add 3 to both sides. So I'll get 3 is equal to 4x. And now, if I divide both sides by 4, I'll get x is equal to 3 over 4. And now we have all we need to graph this function. So let's do it. Let's use this information that we just figured out to help us graph my function. Well, first we know the vertical asymptote is x is equal to negative 3 over 2. So if we take a look at our graph here, well, x is equal to negative 3 over 2. Negative 3 over 2 is the same thing as negative 1.5. And on my graph, x is equal to negative 1.5 is going to be here. So I just need to draw my vertical asymptote at here, at x is equal to negative 3 over 2, negative 1.5. And remember, you want to draw your vertical asymptote using a dashed line. My horizontal asymptote is at y is equal to 2. Right, so y is equal to 2 right here. So I'm going to draw a horizontal line at y is equal to 2. There we go. My y-intercept is at negative 1. So I'm going to draw a point right there at negative 1 on the y-axis. And my x-intercept is, if you scroll down, 3 over 4, or 0.75. So I'm going to plot a point at 0.75 on my x-axis. Now I can draw a curve connecting my points together. And I know as my graph goes further and further to the right, my curve needs to approach my horizontal asymptote. I also know as my graph approaches the vertical asymptote here, I need to draw the curve approaching that line. Okay. I'm not done though. Right? We know there's going to be a curve somewhere on the left side as well. And the question we need to think about. Okay, on my line here, well, should I draw my curve here on the left, or should I draw it on the left like this? Sorry, on the top like this, or should I draw it on the bottom like this? Well, let's think about that for a second. Well, first of all, if I drew it if on the left hand side, if I drew it below my horizontal asymptote like this, then my graph would have another x-intercept. But my graph only has one x-intercept. So this doesn't make sense, right? My graph cannot be below the horizontal asymptote on the left here. That doesn't make sense. So what does that mean? It needs to be above the horizontal asymptote to the left here. Right? And the reason I know that is because it only has one x-intercept. If it was below, then it would have to have two x-intercepts, which we know can't be the case here. So, to summarize, what did we do? To graph functions in the form ax plus b divided by cx plus d, what we did is we found the equation of the horizontal and vertical asymptotes, we found the x and the y-intercept, and we used those to help us graph the function.